In this chapter, we will be introducing the concept of radicals. In this lesson, we'll be looking at how to multiply radicals.
Okay, hi everybody. So now we're going to take a look at multiplying radicals. Okay? So to multiply radicals, the index must be the same. So you can only multiply radicals that are the same, that have the same kind of root. Now there is a way that you can do this if they're not the same, but it involves changing the form of the expression. And so for right now, we're just looking at things written in the form of a radical. So if that's the case, I can only multiply square roots by square roots, cube roots by cube roots, fourth roots by fourth roots, and so on. And when you do the multiplication, it's actually really easy. You multiply the coefficients, and then you multiply the radicands. But you don't multiply the coefficients by the radicands, okay? Those are kept separate. And then you can simplify if you can. In some ways, it's similar to multiplying fractions. You multiply numerators, you multiply denominators, and then simplify. Multiply coefficients, multiply radicands, and so you're going to get a times c multiplied by the square root of b times d. Okay, that's it. That's all you got to know. Now, it's often easier to simplify first and then multiply the outsides or the coefficients by the coefficients and the radicands by the radicands. Okay, sometimes the simplification will make that easier right off the bat here. And then in addition, the other thing you got to worry about here is when you're expanding a binomial, make sure that every term gets multiplied, every term in the one binomial gets multiplied by every term in the other binomial. Such a common mistake to think that square distributes to both of those terms and you just square the first term and the last term. But you don't. You do square those terms, but then you also multiply the outer and the inner terms together and the outer terms together and then the inner terms together. And so a lot of times people forget that oi term, the outer and the inner together there. We'll take a look at some examples of that in a bit here, but that's the pattern here, okay? So notice that we multiplied root 2x times root 2x. We put those together, we get root 4x squared, and then we simplify. But we can also multiply root 2x by 4 to get 4 root 2x. Okay, that becomes a coefficient, and this is the radical. Because this one didn't have a radical, I don't multiply them together. I just leave them as an expression where I'm saying that they're multiplied together, but I don't actually do it. I don't take it one step. I don't multiply the 4 by the 2 or anything like that. I leave it written like that. Okay, that might be a little bit confusing if this is kind of your first time working at this. So let's just take a look at some examples, and I hope that after you see a bunch of examples, the pattern makes sense. Okay, so this question simply asks us to multiply each pair of radicals together. Okay, so root 7 times root 2 will be root 7 times 2, or the square root of 14. And because this 14 doesn't have any repeated factors, that's as good as it's going to get. Now over here, watch, I'm going to get root 10 multiplied by root 10. Well, I already know that's going to be 10 times 10. But then when I think about my rule for simplifying, and normally I'm looking for pairs of factors. Well, I've already got a pair of 10s there. So I could go through, for example, and say that this is the square root of 100. But I can see right now that's just going to be 10. That pair of factors is going to come out and it's going to leave nothing inside there. 3 root 5 times 6 root 3. Well, I'm going to multiply my coefficients together and I'm going to multiply my radicals together. So 3 times 6 is going to be 18. 5 times 3 is 15. Because 15 doesn't have any repeated factors in it, that's as simple as it's going to get. So I leave it there. Negative 2 root 5 times 4 root 5 is going to be negative 2 times 4 multiplied by the square root of 5 times 5. Now, I might make that 25, but I can see right now that I've got a pair of 5s in there, so I'm going to pull that out. So I'm going to get negative 2 times 4 times 5. Well, negative 2 times 4 is negative 8 times 5 will give me negative 40. 3 root 6 squared. Now, because I've seen all sorts of people make mistakes here, my recommendation is that you write it out. Write it like this. And then this becomes 3 times 3 square root of 6 times 6. Okay, well, I got a pair of 6's there. Okay, so that pair of 6's is going to come out. This will be 3 times 3 times that extra 6. There was nothing left in the radical, so I don't need to write it anymore. 3 times 3 is 9, times 6 is 54. And then finally over here, negative 8 root 6 times 2 root 3. Well, it's going to be negative 8 times 2, square root of 6 times 3. Okay, well, negative 8 times 2 is going to be negative 16, and 6 times 3 is 18. Well, now, I didn't see it right away here, but I recognize 18. I know that 18 can be simplified. That's the same as, let's say, 9 times 2. 9 is the largest perfect square. That's a factor of 18. So I can split that up like that, and I know that the square root of 9 is 3. And then negative 16 times 3 is going to be negative 48 root 2. Now, okay, I did that pretty quick, and I did a whole bunch of steps here. The more confidence you get with this, the faster it's going to go, and the less steps you'll have to do to get the answer. But I'm hoping that everything that I did there made sense. I multiplied the coefficients, multiplied the radicands. Then I noticed that that radicand could be simplified by pulling it apart, okay, into a perfect square, and then what was left over. And then I simplified the perfect square and reduced the coefficient. Okay, this question simply tells us to find the following products. But notice in this case that in all of my questions I'm seeing x's and y's. So I'm seeing variables in here. Okay, so this is going to be 7 root x multiplied by 2 root x will be 7 times 2 multiplied by the square root of x times x. Well, I see a couple of x's in there, so I know that I can pull out an x. It should leave nothing left behind, so it's going to be 7 times 2 times x, or 14x. That worked out kind of nice. Over here, multiply my coefficients, that's going to be 9 times negative 3, and I'll put that in brackets because of the negative. And then this will be the square root of b times b. Okay, there's a pair of b's in there, so a b will come out. So this is 9 times negative 3 times b, so negative 27b. There you go. Over here, 11 root x multiplied by 6 root 3y. Okay. But still, I'm only multiplying coefficient by coefficient. So 11 times 6, and then radicand by radicand. So x multiplied by 3y. Well, notice that there's no repetition of factors in the radicand. So that actually, that is about as simple as that's going to get. But I can simplify the coefficient to get 66. Root, and then I might just put this in an order that looks a little bit better. I'll put the coefficient out front there. So 66 root 3xy. And that's the simplest form. Okay, let's take a look at this question here. Amy and Rahima are determining the radical product 2 root 12 times 4 root 18. Okay, so Amy noticed that the index to be the same in both radicals, so she multiplies the coefficients, then multiplies the radicands. Then converts the answer into simplest mixed radical form. Okay, and we're supposed to show her method here. So let's do it. So 2 root 12 multiplied by 4 root 18. Okay, well, we're going to multiply the coefficients together, and then we're going to multiply the radicals together. So 2 times 4 is 8. That's easy. Okay, we know that one. 12 times 18 is 216. Okay, so now what she's going to do is she's going to split that apart, break apart that radical, and put it in simplest radical form. Well, probably when you're dealing with a big number like that, maybe I want to put that in terms of its prime factors. So, whoops, sorry about that. I'm going to divide 216 by 2, and that gets me 108. So actually, here, I'll show you. So here's my 216. So I multiply 12 by 18, and then divide by 2. I know it's divisible by 2. That's 108. I know 108 is also divisible by 2, so I'm going to put another 2 there. That leaves me with a 54. Well, I know 54 is divisible by 2. Oh, that leaves me with a 27. Okay, this is good because I know 27, okay, because of past dealings with it, that's going to be 3 times 3 times 3. So I can take 27 and just rewrite it as 3 times 3 times 3. So here we go. Now to simplify this, each pair of factors is going to come out. So that's going to be 8 times 2 times 3, but I'm still left with a 2 times a 3 under the radical. Okay, well 8 times 2 is 16, times 3 is 48, 2 times 3 is 6. So there we go. So she gets 48 root 6. Now, Rahima looks at the same problem, but notices that she can simplify both radicals first and then multiply. Okay, so we start with 2 root 12 multiplied by 4 root 18. Okay, so what Rahima notices is that I can write this as 12 is 2 times 2 times 3, and 18 is 2 times 3 times 3. And again, I'm doing that because we've already seen 12 and 18 go by a few times already. So we take the pair of 2's, pull out a 2, take the pair of 3's, pull out a 3. So this is going to be 2 times 2 times root 3. Okay. Oh, sorry. For some reason my multiplication turned into an addition and I don't know why. So let's put that back. This will end up being 4 times 3 times root 2. So this is 4 root 3 multiplied by 12 root 2. So that's Rahima's first step, is she simplifies both of those radicals, and now she just multiplies the coefficients, okay, and the radicands. So this becomes 4 times 12 multiplied by root 3 times 2, and there it is again, 48 root 6. So it didn't matter how we went about doing that. It didn't matter whether you simplified first or later. You still get the same answer. So it's kind of up to you to choose which way makes the most sense to you. Okay, so this question says to determine the area of the rectangle, expressing your answer in simplest mixed radical form. Okay, well this is a classic example of an application here, although I suspect you'll hardly ever run into rectangles where they're expressed like this. But the idea of modeling the multiplication process just by using an area question here, that's great. You see that a lot here. So 5 root 32, there's your length. 2 root 16, there's your width. Okay, so do we multiply first or do we simplify? Well, I am kind of partial to the idea of simplifying first, mostly because it keeps me from working with really, really big numbers. So 32, I can divide that by 2, which gets me 16. And then 16 is 2 times 2 times 2 times 2. I know that there are 4 2's in 16. And then over here, 2, and there's my 16 again. So 2 times 2 times 2 times 2. I know that there's 4 2's in 16. So in this first expression, I can pull out a pair of 2's and a pair of 2's. Each one of those is going to spit out a 2 that gets multiplied through, and then I'm left with a root 2 there. In 16, I'm going to pull out a 2, I'm going to pull out a 2. Then actually, that left me with nothing. So this was just going to be 2 times 2 for that pair, and then times 2 for this pair. Okay. Wow, I got a lot of 2's here. So when I multiply this all out, there's no radical over here. So this is 5 times 2 times 2. That's those, or should I say those factors right there, multiplied by those right there, 2 times 2 times 2. And then that root 2 is kind of all by itself here. Well, now what is this? 5 times 2 is 10, times 2 is 20, times 2 is 40, times 2 is 80, times 2 is 160. Root 2. And so there's my area, and it's going to be whatever units squared are implied by this problem. Okay, so now to finish off this lesson here, we're going to look at the same thing here, but we're going to look at binomials. All this does is add just one extra level of consideration here. So for example here, root 5 times root 2 plus root 3, I just have to distribute the root 5. So this is root 5 times root 2 plus root 5 times root 3. And that's going to get me, when I multiply the radicals together, the radicands, it's going to be root 10 plus root 15. Now notice each one of those has only the two factors in it, but they're different. So this is 5 and 2, this is 5 and 3. So I can't simplify that any further. That is as far as that goes. I'm done. Here, I'm going to distribute the negative root 3 to the 4 root 6 and then the negative root 3. Now notice that the coefficient here is negative 1. So when I distribute this to the first term, it's going to be negative 1 times 4, and then 3 times 6. I multiply the radicands together. Then it's going to be, okay, that negative 1, if you will, multiplied by this negative 1, and then root 3 times 3. Well, that's going to get me negative 4 root 18 plus, because the two negatives here will cancel. And actually, I can simplify this down right away here, because I got two 3's inside there. Well, that's going to pop out as a single 3. There we go. Now, I'm not quite done, because I recognize 18. I know that 18 has got a 9 and a 2 in it. And I know that I can take the square root of 9. So it's going to be negative 4 root 9 root 2 plus 3. The square root of 9 is 3, and I'm running out of room here. So this is 3 times negative 4. It'll be negative 12 root 2 plus 3. I can't go any further than this. I can't add, for example, the negative 12 and the 3 because the 3 does not have the radical with it. Okay? So before I could move over to that addition, I'd have to do this multiplication. And since I don't know what that product is going to be, I'm just leave it like that. This one. 4 root 6 multiplied by 3 root 2 minus 3 root 5. Okay, so I distribute the 4 root 6 to both of those terms. So first of all, 4 root 6 times 3 root 2. So 4 times 3 root 6 times 2 minus 4 times 3, when I distribute it to the 3 root 5, multiplied by 6 times 5. Well, 4 root 3 is 12. Sorry, 4 root 3. 4 times 3 is 12. But so is 6 times 2. 4 times 3 is 12. And 6 times 5 here is 30. Okay, now I'm going to try to simplify this. 12 I recognize. I've worked with 12 before. I know that's 2 times 2 times 3. So I'm just going to pull out its prime factors. Okay, 30. Well, 30 is 6 times 5, so that's 2 times 3 times 5. But none of those factors repeat. So I'm not going to be able to simplify that. That is as good as that's going to get. Here, though, there's a pair of 2's, so I can take out a 2. So this is going to be 12 multiplied by 2. That root 3 was left over. And then 12 times 2 is 24. So 24 root 3 minus 12 root 3. That's as good as that's going to get. Okay, now we're throwing some variables in here. Okay, let's see how that changes things, if at all. So root x times 4 root x, well, I multiply the coefficients, so it's going to be 1 multiplied by 4 multiplied by the square root of x times x. Plus, when I distribute that root x to the 3 root y, the coefficients, again, 1 multiplied by 3 multiplied by, the square root of x multiplied by y. Well, there's not a lot that can be done, but there is a pair of x's here. So 1 times 4 is 4, and then multiplied by that x that came out. Plus, 1 times 3 is 3. And since under this radical, each factor only shows up once, the best I can do is just write it as the square root of xy. That's it. All right, now we go to the next. Now we've got binomial multiplied by binomial. So a little bit more is going to happen here. So first of all, the root 2 gets distributed. It gets multiplied by the root 6. That's going to be root 2 times 6. Plus, now the root 2 gets multiplied by the root 3. So root 2 times 3. So that's the 2. That was the 2 getting distributed to both terms in this binomial. Done. Now I look at the 5. So this becomes root 5 times 6 when I multiply those two radicals together. And then I multiply the root 5 by the 3. So this becomes root 5 times 3. Now let's simplify. So this will be root 12 plus root 6 plus root 30 plus root 15. Well, not a lot can happen here. Except that I've worked with 12 before. I already know that this is going to be 4 times 3. But 6 is 2 times 3. Each factor only shows up once. 30 was 5 times 6. And 6 is just 2 times 3. Every factor in 30 only shows up once, so that's as good as that's going to get. And 15 is just 5 times 3. There's no duplication, so that's it. That's as good as it's going to get, so that becomes just root 15. So here, the best I can do is pull out the 2 because of the 4 there. The square root of 4 is 2, so 2 root 3 plus root 6 plus root 30 plus root 15. That is as good as that's going to get. And I'm done. Now, this one right here, the anticipation is that a lot of people are going to get this one wrong. Because there is a rule out there about distributing the exponent, but that's only if it's multiplication or division within the parentheses here. If it's addition or subtraction, you are far better off doing this. Because then you're less likely to miss the hidden terms inside there. So now I'm going to do just like I did in the previous question here. That root 2 gets distributed to both here. So this becomes root 2 times 2 because I multiply the radicals. This is a positive multiplied now by a negative radical, so negative root 2 times 5. This is a negative. Now I'm done with the root 2s, so now I move over to the root 5s, the negative root 5 in particular. So negative 1 times positive 1 is negative 1, and the root 5 times 2. Negative 1 times negative 1 is positive, and then this is going to be root 5 times 5. Okay, well there's some repetition here, so a 2 will pop out. So that's going to be 2 minus root 10 minus root 10, and then there's a pair of 5s there, so a 5 pops out. And now I simply add the like terms. So I've got 2 negative root 10 terms, so it's negative 2 root 10. And then the 2 and the 5 there combine to give me a 7. So 7 minus 2 root 10. And I can't combine those two together because remember that radical there gets combined with the 2. I could only combine them if the 7 also had a root 10 behind it. So that's it. Okay, now there's a little bit more going on. That's okay though. So we're just going to distribute. So 2 root 3 times 4 root 2 will be 2 times 4 root 3 times 2 plus 2 times negative 1 and then root 3 times 3. Okay, plus 4 times 4 root 2 times 2 plus 4 times negative 1, yikes, I'm running into this one, root 2 times 3. Oh, yeah, I'm running into that one. It's getting a little bit messy there. I tried not to, but anyway. Okay, so let's simplify all the expressions here. This will be 8 root 6 minus 2. Now, there's a pair of 3's in there, so I'm going to take a 3 out. So that'll be multiplied by 3 plus 16. And then once again, there's a pair of 2's. So that's going to pull a 2 out. But this is going to end up being minus 4 root 6. Okay, well, I've got 8 root 6 and a minus 4 root 6 over here. So together, that's 4 root 6's. This is minus 6 plus, what is that, 32. So these are like terms, although the coefficient here, sorry, the radical term isn't. So I'm just going to add those two together. So 32 minus 6 is going to be 26. So 4 root 6 plus 26. There's my answer. Okay, well I ran into this one a little bit here, so I'm going to drop it down a little bit. But the pattern is the same. I'm still going to distribute. It's a binomial, so it's going to be 7 times 4 plus, now notice this is just a coefficient multiplied by a radical, so 7 root 6. Here, now that I'm done with the 7, I'm going to distribute the negative 6 through, so it'll be negative 4, and then the 4 doesn't have a radical, so it's just going to be this radical there, root 6. And then minus 1, and then root 6 times 6. Okay, because it's going to be subtract and multiply by negative, the negative, and then there's a positive coefficient in front there. That's why that ends up looking like negative 1, and then 6 times 6. So 28 plus 7 root 6 minus 4 root 6. Because there are two 6's inside there, a 6 pops out. but there's a -1 there, so it becomes -6. And so now I can put together the like terms. 28 and the -6 will be 22. 7 root 6s minus 4 root 6s is 3 root 6. So 22 plus 3 root 6. And now over here, actually I'm going to go a little bit lower with this. So I'm going to bring this down again. So 2 root 18 minus root 27 squared. Okay. What I'm going to do here is I'm going to simplify this first, even before I get to the squaring, because I recognize that 18 and 27 can be simplified. So that's 2 times 18, and I'll write this out in prime factors, is going to be 2 times 3 times 3. And 27 is root 3 times 3 times 3. Well, I can take out a pair of 3's here, and I can take out a pair of 3's there. So this is going to become 2 times 3 root 2 minus 3 root 3 squared. Okay, because that 3 survived, and so did that 2. So this is 6 root 2 minus 3 root 3 squared. Okay. So I haven't even gotten to the squaring part yet. All I've done is simplify the expression. And because it is squaring, I'm going to just write this out again, just so that I reduce the likelihood that I miss a term here. And so now this becomes 6 times 6 times root 2 times 2 plus 6 times -3 times root 2 times 3 minus 3 times 6 root 3 times 2 when I distribute this term through, minus 3 times -3, woo, 3 times 3, almost off the page again. So I've got to make sure I read that carefully. Okay, well the pair of 2's is going to come out, and so this will be 6 times 6 times 2. Well, 6 times 6 is 36, times 2 is 72. Well, the 2 and the 3 in there, this is going to be a 6, so nothing's going to come out. So this will be negative, what is that, 18 root 6. This will be negative 18 root 6. That's kind of cool. A 3 is going to come out of here, so I've got a -3 times a -3, that's going to be positive 9, times that extra 3 from the radical will be positive 27. Okay, and putting together like terms, 72 and 27, well that's awesome, that's 99. And then negative 18 root 6 minus 18 root 6 will be negative 36 root 6. And there you go. So there's a bunch of work involved with that. But I'm hoping that you're seeing that even as the questions get a little bit more complicated, they're really just getting longer. But what we're doing is the same thing over and over and over again. When these questions get longer, just take it easy, do it step by step. Don't try to do too much in one go.